If it's dull, dirty, or dangerous, let's find a way to automate it using robotics. Traditionally, anything that's doing any kind of automation in a manufacturing line is considered to be a robot. As companies start to electrify, what they find is that these machines that were traditionally diesel-powered become very expensive as electric systems. Our vision can now be used to build really large humanoid systems that are doing things that humans couldn't do. It's amazing what you can do when you're really tested. I was doing robotics because I enjoyed the process and the creative problem solving, but there was a whole other dimension of it that got me interested.
That is Hiten Sonpal, CEO of RISE Robotics in Somerville, Massachusetts. Hiten has rich experience in the evolution of the robotics industry, inspired by his early childhood love for LEGO. He has played an instrumental role in many of the industry's innovations, making an impact on the front lines of conflict and in our very own homes. At RISE Robotics, he is driving systematic change in automation to support future electrification of many essential industries that support our daily lives, using his superpower of decreasing time to market of complex robotics products. My name is Peter Marcus Bach, and this is the Grand Challenges Podcast, a show about inspiring individuals who are stepping up to tackle the global challenges that our world is facing in their own unique ways. We reflect on the many out-of-the-box ways our guests have navigated the complexity and intricacies of our environment at the cutting edges of science, engineering, technology, and design. On today's show, Hiten and I explore the robotics landscape, touching upon his early fascination to its many forms and functions in our present day. We discuss how robots can help improve our quality of life, his journey through the industry including the hardships and challenges, and how RISE Robotics is pioneering a novel Beltdraulic system to replace traditional hydraulic operations with a threefold efficiency and with substantial sustainability benefits. Visit tgcpodcast.show for detailed information and show notes on this episode. Thank you for joining us today, and please enjoy the show. It's great to have you here today, Hiten. Welcome to the show.
It's really good to be here, Peter.
And you're all the way in Massachusetts?
Yes, that's right. We're in Somerville, Massachusetts, right next to MIT. And the company was founded by three founders that went to MIT and one founder that went to the Rhode Island School of Design, which is really well known in the area, but not as necessarily well known internationally. But the four of them started the company. And so that's why it's located in Somerville.
And that company being none other than RISE Robotics. So foreshadowing listeners for the topic we're going to cover today.
Well, I guess I'll start off by saying we have an interesting name, RISE Robotics. And the company is named RISE Robotics because the founders of the company wanted to build an exosuit. That was their dream. Think Iron Man, but without the jetpack. And they had this journey where they had to figure out how they were going to amplify human performance. And in that process, they realized that existing technologies that they could use to provide the necessary forces were inadequate and complicated and leaky. I'm referring to hydraulics, of course. And they couldn't move very fast also. And so they ended up inventing a new technology that we called Beltdraulics. And once they had invented this technology, they also recognized that tackling an existing market and disrupting an existing market was faster than trying to invent a new exosuit market. The hydraulics market is over $600 billion of revenue a year. So it's prime for disruption. It has not really changed much in the last 50 or so years.
Oh, wow. And so, from exosuits to now what you're doing in Beltdraulics, and that's something that we'll definitely cover as the show progresses. But before we get into robotics, one thing that you mentioned when we first met was that you are actually a drummer and that you like rock music.
That's right. Yeah. I grew up in India playing this instrument called the tabla. And the tabla is a very complex instrument, and there are lots of ways to get tones out of it. But ultimately, it's a percussion instrument. And it's also taught verbally. So, my instructor would put a set of sounds and pauses together, and I'd have to memorize those and then have to translate them on the drums. And then I came to the United States to go to college, and there really wasn't a tabla instructor nearby. And so the next closest percussion instrument that I was interested in playing was a drum set.
Okay.
Yep. And so I went to school at this liberal arts school called the University of Evansville. They had an engineering school, but they also had a music program and a liberal arts school. And so I headed over to the music department and then signed up for drum lessons. And that was almost 30 years ago. And I've continued that passion since.
I'm one for puns, but it's literally music to my ears because it reminds me of my own journey when, I grew up playing piano since I was 4. And listeners can't see it, but you can see behind me, I still have a keyboard here. And I try to dabble every now and then. But yeah, I wanted to actually go deeper into music, but ended up deciding to do engineering instead. But yeah, definitely a similarity there in our journeys. And in regards to robotics, another area which I felt, pulled back to my own childhood, because I almost went into mechatronics before switching over to civil engineering, because the idea of robotics in a way fascinated me at the time. This was back in, I guess, the early 2000s. But what's your story? Like, how did you get into robotics rather than the liberal arts and pursuing your drumming and percussion passion?
Yeah. So, as I mentioned, I grew up in India and I had some family in the United States, and they brought me a Lego kit for one of my birthdays. And Legos were available in India, but rare and very expensive. And we certainly couldn't afford them at the time. But I started playing with this kit and I developed this huge fascination for building new things from the same set of bricks. So the instructions were interesting for the first 30 minutes or an hour, and then after that, it was, okay, what other things can I make out of these things? And so they sparked my creativity at a very early age. And I started to get a mechanical intuition, at least of structures. So this connects with your structural engineering, civil engineering paths that you were talking about. So that was fine because, these were the early 2x4 bricks. And then I kept asking the same family member that, the next time they'd come visit India, hey, can you get me another kit and another kit? And so they'd visit every 2 years, and every 2 years I'd get another kit. And the kits got more and more sophisticated. So first it was just, as I mentioned, 2x4 bricks and that you could do things with. And then it started to transition to these space vehicles, which were also cool and exciting with the small minifigurines. And that was fun. And the parts got more and more sophisticated, so I could build more and more interesting things. And eventually I got my hands on a Technic kit and I was completely blown away. And so it was the Technic kit of a crane that had a pneumatic system. So you could pump it and it would open up the crane's jaws and would grab something. It was a fascinating kit.
Once again, I mean, you keep bringing me back to my childhood, because I somehow believe we might have played with the exact same Lego crane set. And I played a lot with Lego as well in my childhood. But I remember my first Technic set was a pneumatic crane.
I think one of the incredible things is just that both of us played with the same Lego kit. I'm trying to find what the name was.
It was a small one. I had a small one. And then I had the helicopter, which was motor driven, which you could also build into a dinosaur. And then after that, I got a barcode truck. So I think that was a full hydraulics plus. You had a device which you scan barcodes for truck actions, and you can program the truck to do certain things. Yep. I remember those sets.
Do you remember the number 8040?
8040? No.
That's the Lego kit number.
Ah, okay. Let me check.
It'd be LEGO Technic 8040.
Yes, that's the one. I think that's the one. Or at least, yeah, that's the one. It had a pump, and you use the pump, and it does stuff.
Yes.
Wow. I mean, yeah, memories. Maybe I should get one for, how do you say, what's that word? You get one to reminisce for nostalgia's sake. I guess we have nostalgia buys nowadays. Nah, fascinating.
And then at the last page, there was a teaser, and the teaser basically said, if you have a motor, here's what you can do with the kit. And I was like, we have to get a motor. I have to get this thing to move on its own. And that's when I started talking to my dad and saying, hey, I really want to get a Lego kit. And the first kit I bought was one that had an electric motor and a bunch of other parts. And then I started working with motorized kits. And that was my introduction to mechatronics and getting into mechatronics.
I didn't quite see the motor ad at the end, but I can imagine, Lego and their sales pitches, they can easily then, upgrade these sets and get kids to then, play more with it. I certainly then experienced the same pleasure you had with a set that had a motor later on, but no, definitely a very interesting way to get started. I guess it's the same kind of inspiration that got us interested in robotics in the first place.
Eventually, my dad bought a PC and I started learning how to program. And so then I started to stitch the two things together. And I had this passion for robotics. So I was trying to build things together. I didn't have a really good understanding of electronics. I could do motors and I understood how batteries worked and electromagnets and things like that. But getting into circuits and chips and so on, I'd read books about them, but not having a mentor, especially in high school, didn't know how that all worked.
Yeah, I guess one of the challenges with, being interested in robotics in the first place is that it is a kind of discipline that combines a number of aspects. You got a computer and you started to work around with the software side of things after playing with the hardware. But how did you then figure out that you needed to start somewhere? Was it going to the US to study to get that full package around robotics? Because I noticed that you actually ended up studying a bachelor's in computer engineering at the University of Evansville next to your liberal arts.
Yeah, so I wanted to understand more about the pieces that I was missing, the programming aspect and the electronics. And I thought a degree in computer engineering would cover those bases. For whatever reason, I wasn't as interested at that time in the mechanical engineering aspect of the system. So then I decided I wanted to go to school for computer engineering so that I could do more programming and electronics. And those seats in India were very difficult to get. So if you wanted to do computer engineering in a state-run school or a state university, which was something that we could afford, you had to be in the top 50 out of, I don't know, almost 100,000 students
Oh, wow.
that were
Highly
taking the
competitive.
test. So it was very, very competitive. And it was easier for me to take the SAT, apply to a school in the United States, and then come to the US to study. And so that's what I ended up doing because I really, really wanted to study computer engineering. And so after I arrived at the University of Evansville, I made it a point to join as many student contests as I could. So the IEEE would have these contests where you'd have to build a robot. So you'd have to integrate electronics, mechanical systems, software, and then go compete with other student groups from various universities. And that was a lot of fun. But then for my senior project, I decided to build a chess-playing robot. At that time, chess was a hobby, and I was interested in combining that with the robotics pieces that I was learning.
So you acquired the necessary skills, at least you had the basics down, and now it was time to, I guess, put it to the test. But I'm surprised that it's chess and not drumming.
Yeah, the chess problem seemed a little easier. One of the things I noticed is that a lot of students would work on these big, ambitious projects and wouldn't finish them. And so the most important goal for me was whatever I pick, I should get it across the finish line. And so picking something that I thought was achievable made sense. And I also knew that I couldn't do it all by myself. So I did need to find a teammate. And I had a friend from Jordan who was the mechatronics engineer. And I tossed out the project to him and said, should we work together in this? We'd been in some classes together and really respected him. So the two of us formed a team, and that was our joint project to build this chess-playing robot.
Very, very nice. And I know chess itself, it seems to be the litmus test for many, whether it's software or whether it's software-hardware combinations and robots. But also a very challenging thing to build because, how do you then program the robot itself to coordinate with the thinking part of it and to also recognize how the player that it's playing is making its moves? So how did you navigate that chess problem in the first place and then implemented it?
That's a really interesting question. Before I get into that, I should probably answer also why chess with another dimension. Deep Blue was in the news at that time. This was the supercomputer that IBM had built that had just recently defeated Garry Kasparov, who was the champion. And that was the first time a computer had beat a human at chess. And so that was in the news and that was popular. So I said, okay, let's build something that will actually move the pieces. And I wanted to be mindful of not taking on too much. As you mentioned, the chess problem itself is hard enough. And then to manipulate the pieces and move them all. So what I ended up doing is picking an open source chess engine. The one that I found that was easiest to interface with was this engine called Crafty. And it could interface with this program called Xboard. So you could see what the engine was thinking. And then we basically inserted a microcontroller between the output. What you call in Unix is a pipe between the output of the engine and the input to Xboard. And so by looking at what moves the engine was putting out, we could basically take those and send them to an arm that would then move the pieces around.
Okay. Simplifying assumptions, but then also, working with what's already out there and available.
That's right. And what was available at the time in terms of cameras were these webcams. And these early webcams were terrible. They had a lot of spherical distortion. The lenses weren't as good as they are with the cameras that we have today. And so instead of getting a square picture, we got a weird oval, with the straight lines all curved and stuff. And that's where I ended up putting most of my time, is figuring out, okay, where are the lines of the board and how do I straighten this thing out? And sometimes, depending on how the board was set up, it looked like a curved trapezoid, and I had to figure out how to get it in the right orientation and stretch it out properly so I could find the right pieces. And then the other part I noticed was that it was very hard to tell the pieces apart with the particular webcam that we were working with. And it was especially difficult to see black pieces on black squares. The chessboard itself was a black and red chessboard with black and white pieces. So the white pieces showed up everywhere, but the black ones wouldn't show up on black squares. So I ended up modifying all of the pieces so they had a red ring around them. I took the checkers pieces that came with the kit. It was a chess and checkers kit. And I glued the chess pieces on top of the checkers pieces. So all the black pieces had a red ring around them, and then all the white pieces had a black ring around them. And we were able to then at least see the pieces. The next step was identifying the pieces, and we didn't have any of the machine learning capabilities that we have now. There was no libraries. We certainly couldn't parse things in 3D. Everything was in 2 dimensions. And what I ended up doing was making the assumption that the people who were playing chess knew the moves. And so I knew that there was a piece at position X and it would move to position Y. And just by remembering what piece was at position X, I would be able to figure out what piece had moved where. And then I would feed that information back to the chess engine. So there was a little bit of guessing happening there. Certainly, if somebody had quickly swapped 2 pieces, which was an illegal move, the chess engine wouldn't have known, but it would have known that that piece needed to be a knight. And even if someone had swapped it out with something that looked like a queen, it would still expect you to move it like a knight.
Interesting. Yeah, I guess at the time, with all the challenges, you had a pretty big mountain to climb, but somehow you managed to solve a lot of these potential roadblocks. And yeah, you can't build the most perfect robot arm to play chess in a short amount of time. I guess this was a pretty limited window that you had to build it. But the key was also demonstrating how you could transfer the software and the intelligence into a robotic arm, and to use computer vision at the time, which I think was also in its infancy as well.
That's right. And Peter, thank you for bringing this question up. I now recognize that this is a muscle that really hasn't gone away, that it's gotten stronger, which is, how can I solve the full problem without solving every bit of the problem? For the robot arm, we took 2 printers that had these 2 XY arms, and then we basically turned it into a plotter. So the plotter moved an arm, and the gripper would just move up and down. So we simplified the mechanisms. And also, as students, there's only so much stuff we could buy. So it was easier to find a printer out of the trash and see what we could do with it than it was to go buy. Now you can buy robotic arms for less than $100 that are plastic and have servo motors and so on and so forth.
Oh, really? They become that cheap?
They have become very, very cheap. Yeah.
I should get into robotics more.
That's right. And so we made these simplifying assumptions, and anything that we could buy or acquire, we did. And then we spent most of our time on the integration. And you're right, computer vision was very new at that time. And the first time we tried to demo it, I found out that it wouldn't work because the lighting conditions were different than the lab in which we were doing development. And so I just adjusted the lighting for the demo till it worked. And the professors who attended, and there was a big demonstration, folks came to students kind of demonstrate their projects. So a lot of people came, and a couple of professors, even though I had to change lighting and everything to make it work, were like, this is the most impressive thing I've seen on campus.
That's amazing.
Which is really heartening. And we ended up winning the best project for computer engineering that year.
No, fantastic. Taking inspiration from something that was happening in the industry at the time, as you mentioned, IBM's Deep Blue. I have to be careful not to mix that with AlphaGo, which was much later on. And yeah, I guess expanding upon the idea as well, adding the hardware component, which I feel like nowadays, that seems to be like a normal project. And I guess it's always looking for the frontier and then trying to innovate at that level. And that's in a way what you've been doing over the course of your career as well. So since the chess playing robot, you then went into the company called iRobot for 15 years. And I guess for those who are not familiar with it, there is one thing that I think everyone can relate to, which is the Roomba. Basically the robot vacuum cleaner, which I know my wife has been asking me to get one. We have yet to cave and get one, but I know that's definitely on the shopping list at some point. But what was the journey from the chess playing robot through to iRobot? And I guess that really kickstarted your robotics career.
Yes. So after graduating, I worked for a consulting firm briefly, a design consulting firm. And one of the projects I was working on had iRobot and DARPA as a client.
Mm-hmm.
And we were trying to build soldier portable robots for reconnaissance. And while we were doing that project and we had gotten our first prototypes up and operational, 9/11 happened.
No.
And within 2 hours, we got a call from the general in charge of the operation saying, hey, this is what you were building these robots for. Where are they? Can you get them here? And I was in the Midwest. It just so happened that the owner of the company was a private pilot. He got permission to fly a plane. He was one of 5 planes flying the day after 9/11. He took 2 of the robots down there. The team spent the whole night getting them ready, and then they were deployed at Ground Zero in New York City. And that was a moment where, I was doing robotics because I enjoyed the process and the creative problem solving, but there was a whole nother dimension of it that got me interested, which is the impact that it could have. It went from being, just first an academic project to just work to now affecting lives.
Mm-hmm.
And after that, I made the decision that I was going to find a way to work for iRobot myself, because if they're working on such cool things and making such a difference, I want to go do that. And so a few years later, I had the opportunity and I joined iRobot full-time. The first half of my career was in their government business, and we built and shipped another 1,200 of those robots modified with arms to Iraq and Afghanistan to defuse bombs, which was an incredible experience because we were saving lives on both sides. We were saving civilians from these improvised explosives that were being placed by terrorists, and we were saving the lives of U.S. soldiers who had to go out and defuse these bombs. And if the robots didn't operate, then they'd have to get in a bomb suit. And if the bomb went off, typically the EOD operators would lose their hands because to actually manipulate the wires and so on and defuse a bomb, oftentimes the operators would have to take off their gloves.
Oh, geez.
And so there's a high risk of losing their hands. So once the robots went out and started being used, it completely changed how improvised explosives were handled. Now, the standard operating procedure is you use a robot. You do not send a human out there to do the diffusing. And we made that possible. So it was incredible. We probably saved hundreds of soldiers from getting injured and hundreds, if not more, civilians from getting injured by the blasts.
That's incredible. And I guess you were really in the middle of, the evolution of robotics, because as someone from the outside watching what was happening in the robotics field, yes, you had the chess playing computer, but then I also noticed that I think in the early 2000s and even now, we see often reports of, robots being sent to disaster sites to defuse bombs, to really help areas which humans can't normally reach. And, it makes it a bit safer. It allows more control. And yeah, even sometimes these robots have, they're much stronger, so they can actually work with the rubble or debris or anything that can, that they can encounter, which humans otherwise couldn't. So really that human augmentation as a result of it.
That's right. There's a movie called Hurt Locker, which if folks want to go check it out, it kind of describes the life of an EOD operator that's trying to defuse bombs in these areas. And it kind of describes the journey before the robots got good. The robots were not great and what they had to do with them and so on and so forth. And to your point about robots being capable enough to lift rubble and so on and so forth, later on in my career at iRobot, we shipped 2 robots to Japan for the disaster that happened because of the tsunami at the Daiichi plant. And the robots were used to find out what the level of radiation was inside the reactors before any personnel were sent in.
Yeah.
And those are all capabilities that I think are amazing for robots. I think the mantra is, if it's dull, dirty, or dangerous, let's find a way to automate it using robotics.
That's a very nice mantra, actually. And yeah, it opens up the possibilities of how you can use robots. But in a way also defines why robotics is on the rise and still continuously on the rise, and I guess even booming also with the age of AI. I was just looking up some basic stats about robotics. And the numbers I found were quite mind-boggling. So global market value approximately was about 95 billion US in 2024. This was a stat I found. And it's projected to grow to about 111 billion by 2030. Interestingly, I found that Asia accounts for the largest share, so 74% of industrial robots, of which the Republic of Korea, there's about 1,012 robots per 10,000 employees. I didn't know you could have stats like that really talk about the robot population. It sounds very sci-fi, actually. But apparently, McKinsey estimates that the AI and robotics industry could generate nearly 2.9 trillion US dollars in economic value by 2030. So, that is not a small amount. And maybe to shed some light on how listeners can imagine this kind of field. When you think robots, you normally think humanoid robots. We see a lot of these demos. But I mean, how would you describe this field? What is considered a robot? Anything, from small to large? Anything from humanoid to machine-like?
Yeah, the definition of AI and robots continues to evolve. Traditionally, anything that's doing any kind of automation in a manufacturing line is considered to be a robot. And so they come in various form factors. There could be a robot that is just installing screws. And if you looked at it, it kind of would maybe be a magnetic screwdriver attached to some sort of arm, right? And is it really a robot? It doesn't have a face or, legs or anything like that. But when those statistics are concerned today, all of those machines get counted as robots. And certainly, if we think about the evolution of robots, we're evolving from doing very structured, repeatable processes to starting to take on work that is a little less structured and a little less repeated.
Mm-hmm. Yeah.
Although all of those repetitions are still happening in simulation to train these robots. So for example, when you think about a humanoid robot being trained to walk, you see all the different kinds of terrain it can walk in. And the thought process is, oh, look how capable it is. But really what's happened is that software engineers have created enough virtual environments to train the system so that when it encounters them in real life, it basically knows how to handle them. But so there's this trend happening, and certainly the shape of these systems is starting to change. As folks are looking at more general purpose tasks, they feel that it's necessary to make these robots look more like humans so they can start using all of the infrastructure that humans use.
Interesting.
If you think about traditional manufacturing lines, the manufacturing lines are being adjusted for the equipment.
Okay.
And the vision of humanoid robots is that the robots are capable of using whatever infrastructure is already out there.
I've never thought about it that way. I always thought, well, there's more relatable aspects when the robot is humanoid. And, I guess that in a way has its positives, but I never went deeper than that. So yeah, you shed a very interesting light on that. And it's true. When you think of manufacturing, the most common one being the assembly line for car production, they automated that. You see lots of videos and news reports, when they talk about the economic situations of different car manufacturers, you'll see an insider look into the factory and you have arms pretty much, working like clockwork trying to assemble the car. So never thought of that contrast. But I guess with that, if you're trying to make robots more humanoid, with that comes the need for training. And I guess like us humans, we need to learn to adapt to many different kinds of cases or scenarios, and that could be endless.
That's correct. Yeah, so I think that humanoid robots are still a long way off, personally. A couple of reasons. The first one being that most use cases of humanoid robots can be done in a much less expensive way using a dedicated robot that's designed for that task. I'll give you an example. One use case could be, okay, we've got valets that park cars. Could you have a robot that parks cars? Now that problem is a humanoid robot, right? That problem can be solved without humanoid robots in two ways. One is the cars will get to the point that they can park themselves.
Mm-hmm.
And then the two is, you might have seen videos, there's like a really flat robot that's structured. I think I saw a video on LinkedIn that's designed to go under cars. And it's really very simple. It drives underneath the car. It sort of uses leverage to pick the car up and onto the platform, and then it just moves the car itself. And the price tag for something like that is a lot simpler because it's got 4 motors, 4 wheels, some lifting mechanism, but doesn't really have to have legged motion, which is very expensive. So I see that there are use cases where as soon as people build a humanoid robot that solves that problem, somebody will come in and say, okay, I can do that a lot cheaper with the dedicated system, and we'll seize that market.
Interesting, yeah.
But there are certain cases where I think you're going to need legged systems, and that's usually when you're doing things outdoors. Once you get them outdoors, I don't see their size being restricted to a human size. I see them ending up being much larger humanoid robots that are capable of lifting much heavier things. And that's where RISE comes in. Our vision of exosuits that were designed to amplify humans can now be used to build really large humanoid systems that are doing things that humans couldn't do in a very flexible way.
And we've heard of this idea of exosuits before, where you have someone wearing something. You see there's a lot in action movies with, lots of tech. You mentioned Iron Man as well. And I guess, it makes sense, especially if you want to then bring in, the human control over applications like ones we've discussed already. So, for example, in disaster areas, trying to save people under rubble in the event of earthquakes, or I guess just generally in construction as well. There's a lot of challenges that goes into it as well, isn't there?
Yeah, there are certainly many applications. You mentioned construction. There's also in warehousing, moving things around, lifting heavy things. And then there is elder care, folks that are starting to lose muscle mass. If you could augment them so that anything that they intend to do can be amplified and they can get a little bit more assistance in doing their day-to-day tasks. That's another application. And certainly the armed forces trying to do certain missions where you require more strength than a human might have. So you put on a exosuit and you go do the mission and you come back. So I can see, a wide range of applications there.
And also a wide range of benefits as well. When you think, it's the quality of life improvement, people's mobility, I guess giving people the ability to then, move around and be independent for, certain things as well. I think that's a very liberating feeling and definitely a more humanistic application of such technology.
That's right. And with an aging population across the world, there is going to be demand for a lot of systems to help older humans live out their lives comfortably.
Yeah, definitely. And so with all this hype around generative AI agents, the AI boom itself, what are your thoughts on how robotics is going to change with all this new AI software coming out?
That's a great question. My experience with AI tells me that this long tail where AI isn't able to answer a question or is hallucinating is going to be around for a while. So that's one part of it. The second part of it is that I see that AI is going to be increasingly connected to physical systems.
Yep.
But you still have to resolve this issue of the core intelligence not necessarily being right 100% of the time. And so what happens, for example, in automated warehousing systems is that there's actually a bank of teleoperators that help these automated forklifts get out of trouble when they get stuck or they get into situations that they don't understand. And so what I see is for a long time, there's going to continue to be a need for a human in the loop, a skilled human in the loop. And so I don't see there being a huge impact to jobs right away.
Yep.
The second piece of it is I see this as an opportunity for blue-collar workers to extend their careers. So rather than being outside at a job site working on something, I can see them working from home in a supervisory role where when the robot gets stuck, they have to help it and use their experience to help the robot get unstuck, which over time the robot might learn. But initially, I think there's going to be this need for humans for a long time to look over what the AI systems are doing and to intervene as necessary.
And who with better skills than the blue-collar workers who've done it themselves? And sometimes, you have to mimic what you have done yourself in order to then program it or to design an AI system that can do it as well.
That's right. And the most productive programmers that are using AI systems now are basically being multiplied by AI. They're not being replaced by AI because although the AI systems can churn out code, someone still has to look at the code and say, well, did it just juxtapose two things because they were frequent versus juxtaposing two things because they made sense, right?
True.
So those things still have to be done by humans. So that's what I see happening.
Yeah. So not all doom and gloom. Well, that's good. Optimistic future.
Yes, certainly not. That's not how I don't see the future being doom and gloom.
Fantastic. And so we've talked about, the robots that we wouldn't think are robots, but usually designed for manufacturing processes. We've talked about the robots that are more on the humanoid side. I guess before we get into really the crux of what you do now, which is actually robots that replace a certain process with much greater efficiency, I guess to get to that part of your story, you actually worked in something more or less, I would say, as in between. The robots that don't necessarily have to look like humans, but actually do automated tasks that we, I guess, sometimes don't want to do, such as vacuuming or mowing the lawn.
That's right. The second half of my career at iRobot was in their consumer business. The first half, as I mentioned, was in their defense business. And in their consumer business, I was leading teams that worked on Roombas. And then I had the opportunity to do a clean sheet design of a robot lawnmower, which is the concept was a Roomba for your lawn. And this was something that was in demand by all of our customers. Anyone that met an iRobot employee said, I love your Roomba. Now, can you give me something that cuts my grass?
Really?
Right? Yeah.
I guess it was the house lifestyle that people liked to, have robots taking care of the surface itself.
That's right. Once they got a lot of their time back from a Roomba doing the vacuuming, then they also saw, okay, what are the other chores that this system can do? And a natural sort of adjacent chore for them was, okay, I'm pushing around a vacuum cleaner inside the house. Well, I don't have to do that anymore because of the Roomba. I'm pushing around a lawnmower outside. Well, why can't this same company give me something that does the same thing? So it was a very natural request from all of our customers and a desire from all of our customers. So I led a team that did that. And we finished it right before COVID. And we couldn't launch it because of COVID because there was a substantial impact to the business. We couldn't get our products, which were being manufactured in mainland China at the time, we couldn't get them into the United States. We couldn't sell through Amazon because Amazon was only shipping diapers and bottled water at the time in the United States. We couldn't sell them in malls because malls and retail stores were all shut down because of the pandemic. And so the business was in a very difficult situation. So they really had to go through and cut cost, and they paused every expansion project. So right before launch, the project got paused. And then iRobot picked it up again, but now they've lost their leading position because of a lot of competition. And so they've not been able to launch that product.
No, that's definitely an unfortunate, incident that's happened and affected us all, the pandemic. But I guess it was a topic that you didn't want to give up, and you definitely pursued the lawnmower robot for a few more years after that before joining RISE. And some companies you've been to, aptly named as well. I'm just listing a few. You have Paramo or Mobot or even Electric Sheep Robotics. It didn't strike me at first, but then I realized, hang on, electric sheep. Yes, sheep eat grass.
That's right. And so one of the things I learned while we were working on the lawn mowing robot for consumers was that the price point was aggressive, right? You couldn't make something that's designed for consumers that's going to be more expensive than, say, a high-end laptop. That would be a hard sell, or an appliance, right? It has to be in that price point.
Yeah.
And that limits the amount of tech you can put into the product, which means you have to spend a lot of engineering effort bringing the cost down of every part. Every part has to be designed very, very thoughtfully. It takes many iterations before you get it out to market. Conversely, when you look at the return that a business might get when they're using a robot for lawn mowing. So if you think about a typical lawn mowing crew, you could have a crew of 3 people that are out there going from yard to yard. If you could give them a robot that was automated, then instead of 3 people, they could have a crew of 2 people with the robot doing the work of one of the people while the other 2 people are cleaning up, getting the robot unstuck, and so on and so forth. And so again, we have this demographic problem, and we also have this problem of there not being enough blue-collar workers in the United States. So there is a labor shortage in that whole category. And we saw that there was an opportunity there for robots to be deployed for commercial lawn mowing of residential homes.
Okay.
So I joined a couple of companies that did that. And eventually I was at Electric Sheep Robotics, which was building large form factor commercial mowers for commercial properties. And it was all very exciting because I could see that this change is coming, right? I just didn't see that humans were going to be mowing their lawns for very, very much longer, or cutting grass for very much longer, because you could see autonomous cars coming, and autonomous cars have to go at high speeds. And yes, it's a structured environment, but lawns are more contained, and you can handle the safety issues much easier than you can with an automotive system that's autonomous running on the road. So I felt like it was a problem that could be solved. Now, it's a smaller market than the car market. That's why a lot of the bigger companies haven't targeted it. And the corner cases are extensive. So that's why, a company like Tesla, for example, will probably not look at that as a problem that they want to solve. But there's plenty of opportunity there still.
Oh, definitely. And, if the big companies don't want to look at it, it's an opportunity for you to step in as well and to make people's lives better in a certain way. And automating things around the house then frees up time for people to then pursue other creative pursuits or, other aspects, like drumming or Lego.
That's right.
But nevertheless, when we think about the way you've progressed, you solved the chess problem, you worked and saw how robotics was applied to have real world impact, but really big impact. You then understood how our daily lives could be evolved and changed through robotics. But I guess also when we think about what the future holds for it, and this is really, I guess, what you're targeting now, the more machines we have, the more energy is going to have to go into it. And I guess the smarter the design is going to have to be, because, we are facing an energy crisis, and we often it seems like we have to be more productive in output as well, in our manufacturing, in a number of many things. And so this is where RISE Robotics comes in, from exoskeletons to what you now call Beltdraulics. So you have an interesting technology that you pioneered at RISE Robotics, that you, in a way, are tackling this energy question, but also many other benefits as well for the environment.
That's right. Yeah, I joined RISE Robotics as a consultant at first. I'd finished up my assignment at Electric Sheep Robotics. The venture capital funding had sort of evaporated in the 2022 timeframe, and I was looking to help other companies get their products to market, still using my same passion about helping teams not solve every problem, but really focus on the key problems, really focus on the MVP. And one of the companies that I started consulting with was RISE Robotics. And the way I found them was that a friend of mine was working at RISE, and he told me, and we're just catching up, and he told me what RISE was working on, that they were working on this hydraulics replacement technology. And my immediate reaction was, oh, they're working on screw type actuators. And his response was, no, this is something completely new. And I said, I don't see a way where you would be able to do something, move things linearly without a screw type system. And he said, you need to look at the patents. And so I went online, looked at the patents, and I was excited. I was like, this is a new kind of solution that hasn't existed before. I asked my friend if I could come visit. I met the founders, and they, heard that I'd previously been a CEO, that I was helping solve companies get their things to market. And so they asked me to join as a consultant. And then a few months later, they asked me to join as full-time as CEO. And what we're trying to do is replace these hydraulic systems with our technology called Beltdraulic. What we've done is taken out the hydraulic oil from hydraulic linear actuators and replaced them with belts and pulleys. And by replacing the oil with belts and pulleys, we've ended up with a system that doesn't leak, that runs 3 times as fast, that is 3 times as efficient, and 3 times as durable. And it's also very precise. So it unlocks the transition of heavy machinery from diesel systems to electric systems, but also from human-operated systems to tele-operated systems, and eventually to fully autonomous systems.
So if I understand that correctly, so I guess I'm not the robotics expert. I ended up doing civil engineering, but just to clarify, maybe my listeners would appreciate this. So the actuator, that's really the device that converts energy into movement. And you need that movement, obviously, because robots have to do stuff and they can complete the task. And so traditional hydraulics, any hydraulic system will then need, I guess, quite a bit of, diesel fuel or energy that's pumped into it. Often then you need the oil, and I guess also the machine itself needs some kind of oiling, because otherwise it doesn't move as smoothly. And immediately I can already think, you mentioned pulley system and a belt system. That, of course, is much more frictionless as a result of it. So you've got that. And then you're actually speeding up the process. So if it takes, I guess, a lift, let's say a forklift or something, to move an object 5 meters across, you can do that in a fraction of the time, essentially.
That's correct. And I think your insight about the friction is key here, which is that when you think about hydraulic fluid, it's viscous, and the friction happens between the molecules of the fluid. And that's where a lot of energy is lost. And so many hydraulic systems that are doing any significant amount of work end up having a radiator to dissipate all of the excessive heat that's building up in the oil.
Ah, yes.
And then in addition to that, when you're pushing hydraulic fluid, that force is being distributed evenly across all of the interior walls of the system, right? So it's not just on the moving piston, but at every seal, at every valve, at every interface that's happening between two systems or two parts, that hydraulic pressure is showing up. And so eventually these systems start to leak. And so they need maintenance. And hydraulic oil is hazardous. And so there are some applications like agriculture where you absolutely do not want any leaks, because it's going to end up in food.
No, definitely not. Yeah.
So there are plenty of systems there. And then as companies start to electrify, what they find is that these machines that were traditionally diesel powered become very expensive as electric systems, because you take out the diesel engine and you put in place an electric motor, and then you add a huge battery pack, right, which is your gas tank. And the battery pack has to be very, very large, because so much of the energy is being wasted as heat in the hydraulic system.
Aha, interesting. Yeah. You need the same kind of watts, but to
That's
operate
right.
that same system with a lot of flaws, as you've mentioned already, the leaks, the heat dissipation, etc. Yeah.
That's right. The hydraulic systems are typically 30% efficient. So you're just throwing away 70% of the energy, which means your battery size is 70% larger than it needs to be. Makes the systems very expensive. In fact, the price of these heavy machines doubles. Like if you had a system that's 400K and you converted it to an electric system, it would cost 800K. And many companies just don't see the ROI in that.
There's no incentive at all to convert and electrify as well.
That is correct. The state of California has a target to convert all of its ports to zero emissions by 2030. They're probably going to have to extend that timeline. To help with that process, they've created an incentive structure where they give vouchers to companies that are going to be buying zero emissions equipment, electric equipment, instead of the diesel-powered equipment. But those vouchers run out in the first 2 weeks. So companies sign up, they want to do this. The vouchers make a difference, but the first 2 weeks, they buy all the electric equipment that they can, and then the vouchers aren't available because they're all gone. And for the remaining 50 weeks of the year, nobody buys any electric equipment.
Not quite as efficient as you think it would, often, these schemes.
Yeah, I mean, it's well-intentioned.
Yeah.
So with the belts, what ends up happening is all of the friction is intentional. We have bearings on the inside of these systems that are sealed, so there's no leaks that are happening. And bearings are a well-understood technology, have been around in all sorts of applications and are very reliable. And because we're so intentional, the actuator itself is over 90% efficient. And then when you add a motor on top, typically the highest efficiency motors are on the 85% efficiency mark. So as a system, we're roughly 75% efficient. We are almost 3 times as efficient as a hydraulic system.
I mean, that's crazy. You mentioned 30% just now.
Yes.
Yeah. I mean, that's a huge improvement, but it's also an overhaul of an age-old technology that we thought was sort of the solution to everything.
Yes, hydraulics was, well, yes, it is the state of the art, or rather, it was the state of the art until Beltdraulic showed up.
Yeah. And so tell me some applications that you've already used this technology on. Like, give me an example on the ground of how this technology is being implemented and replacing certain hydraulics that we know.
Sure. So I'll start with the work that we've done for the Pentagon. We've shipped 2 major systems to them. One is a device called a common lifting device. This is a collapsible crane that's used by the Air Force for certain missions. And the requirements were that it not have any electrical components on it. So no electronics, and it's hand-powered. We don't understand the mission in detail, but so it's this hand-powered system that was previously a hydraulic system, weighed 1,800 pounds, and could lift 150 pounds. We replaced that. Yeah, we replaced that with a Beltdraulic system that weighs 300 pounds, can still lift 150 pounds, and takes 3 times as less effort as the previous system.
Geez, I hope you get discounts on oversized baggage and overweight baggage in future for any flights you do, because that's
right.
An amazing improvement.
That's right. The Air Force doesn't give civilians flights, but if they did, they would give us a discount. Absolutely. And because this system actually goes on a plane, we saved them 1,500 pounds of fuel, or we made space for another 1,500 pounds of fuel, which really expands the range of their mission. So they're really thrilled about that. We delivered $1.5 million of this product to them. And then they were so pleased with it that they gave us a follow-on contract to tackle their next main hydraulic pain point, which is munitions handling units. So over the decades, the munitions have gotten heavier and heavier that get put on these planes. And currently, some of the heaviest munitions weigh 7,000 pounds. And lifting them and putting them on the planes is a very complex task. In the existing hydraulic systems, they start off working really well, but within a short amount of time, they start leaking like sieves. They can't hold position, so the operators are manually tweaking the system while people are trying to pin the munition onto the wing. And then after each operation is done, somebody has to come out with a Zamboni and suck up all of the hydraulic oil that was spilled on the ground so that it's not a safety hazard.
Oh, geez. So a multi-step process, because it's not exactly, a perfect procedure.
That's right. And because they're hydraulic systems, they are paired with diesel engines to give them the power, because they have to throw away so much of the power in the hydraulic fluid, in the movement of the hydraulic fluid, as opposed to the actual work being done. So they create a lot of smoke. They're loud, and so the operators are yelling over the diesel engine, and sometimes they have to do an operation inside a hangar where they're ending up inhaling diesel fumes. And certainly, folks that sign up to do this job, they understand that their lives are at risk, but when they're doing exercises and training, that's not the time for them to be inhaling diesel smoke. Like, that does not make sense to me. It doesn't make sense to anyone. And so they requested that we design for them a replacement. And we built them a system that actually got into the Guinness Book for being the world's strongest robotic arm.
Oh, wow.
We built them a completely fluid-free robotic arm that could lift a 7,000-pound munition. They really liked the system, and they've selected us for a follow-on contract of $3 million to take that arm and put it on a vehicle. So they have a demonstration unit that they can evaluate a full system as opposed to just the arm, a system that they can drive around. And that's kind of the next phase. So that's what we're doing for the Pentagon.
I mean, it's incredible when you find that core technology, the core idea, the amount of applications that you can do, much like how you described your first, practical exposure to robotics, in disaster zones, in war zones. But, same idea now. You find a core technology, you can take it so far. And it's incredible to see the different ways you can then, I guess, tweak it, but with the same benefits. And you've mentioned a few different benefits, not just the quality of life, and the efficiency gains, but also the carbon emissions would effectively be zero. Also the weight gains as well that you've mentioned. What other kinds of benefits have you seen emerge from the technology as you've explored its possibilities in time?
So for the Pentagon, one of the things we do is we enable a flex fuel system where they can run the system off of electric batteries, or they can run the system off diesel or any kind of fuel. And one of the challenges of running any kind of mission is the logistics of the mission. And we really reduce the logistic footprint, because even if you ran our systems off of diesel, they would require 1/3 the fuel that they do today, which is a substantial difference, right? Fuel costs $5 a gallon here in the United States approximately, and it costs 100 times that if you take it to the battlefield. So reducing every bit of fuel that goes out there makes a substantial amount of difference.
Yeah.
Never mind the fact that our warfighters are, inhaling smoke and things that they don't need to.
I guess, the choice of electricity, as you mentioned, that's really up to the user itself. And if we're looking at electrification in the future, then at least you've ensured that, the amount required is much less than what conventional machines need as well.
That is correct. And then the additional precision control that we enable means that a lot of these systems can be easily converted to more automated systems where the operator just has to hold on a button. And because the system is so precise, you can use sensors and closed loop feedback to position the system for the operator so things can move a lot faster. They can be more efficient. In addition to the speed gains that you just get the overall system efficiency gains because you can add more automation. And certainly the reliability is much greater because you're not leaking hydraulic oil. You don't have to change it for cold weather. It's the same system whether you're using it in a desert environment or the tundra.
Incredible. But when I think of, belt systems, I always think of the material that the belt and the bearings are made of. I mean, I guess you've designed it as well to have a similar lifespan, if not longer lifespan as well, right?
That is correct. As I mentioned, the forces are all very intentional. So the wear and tear is really only happening on the surface of the belt. And we have really good models as to what it takes to wear these belts down. And we're expecting roughly 3 times the life than a hydraulic system.
You have a system that really ticks all the boxes and improves upon what we know, and really that systemic change that we need if we want to go forward into the future with these kinds of robotic systems as well. And so, what are the plans for RISE Robotics heading into the future? You've got your first few successful contracts. They seem to be coming more and more, and new applications popping up. What's in store?
Yeah, so a lot of my focus is on commercial applications now. We've got really good momentum with the Pentagon. And on the commercial side, there are 3 sectors. One is kind of our North Star that everyone here is excited by, which is construction. We definitely want to be in construction equipment. It's a huge market. Also, big boy toys. A lot of engineers here want to play with them. They would like to have an excavator here that we're converting, and so on and so forth. And logistics would be sort of a step before that. So forklifts and converting those. But in the near term, our focus is on the oil and gas sector. Oil and gas production isn't going away. It's also a very dirty sector. A lot of the energy that's being used in oil and gas production is just wasted energy. So anything we can do to make that more efficient and clean would have a magnifying impact across the board. And we're working with an OEM on natural gas compression pumps. These are pumps that get installed at every oil well. They're responsible for recovering the natural gas and pressurizing it so that it can be sold. And our technology would allow these pumps to run 3 times faster, last 3 times longer, take 1/3 of the energy. And the gains are multiplied because the system is working 24/7. And so what makes this an interesting market for us is that means that we can charge higher margins, which we need to do because we're just starting off as a commercial business and our volumes are low. And as we start to scale, we can get into markets where the cost pressures are higher. But in this particular market, we don't have a ton of cost pressure. So that's one. And then the second segment we're tackling is the marine sector.
Interesting.
And in the marine sector, there's an interest by captains to not have hydraulic oil on their boats. They don't want to see leaks. They don't want to go out to a beautiful spot in the ocean and leave a trail of oil. And so there's a lot of interest in converting all of those systems to being hydraulic oil free. And for the most part, it's a price insensitive market for those that want to convert. And just related to that, the work that we're doing for the oil and gas sector is also going to be applicable to the third sector we're looking at, which is forklifts. So the same cylinders that we use in oil and gas will end up being used in forklifts. So for marines, we just need stuff that can handle salt water a lot more aggressively. So the materials are going to be slightly different. So that's speaking to forklifts. But we also have our own product that we're getting to market that's using our technology as a proof point. And that's a liftgate. I don't know if your listeners know what liftgates are, but if you want to deliver product to stores, you typically load the products in a pallet on a dock, and then you have to deliver it at ground level.
At the back of a building, the truck drives in and there seems to be this big metal plate. And I know that somehow goes up and down to a platform that has the door to the storeroom or the back of the shop.
That's right. At the warehouse, the loading level is at the truck height, the truck bed height. But at most stores, the loading happens on the ground floor. So you need something to bring those products down from the truck height all the way down to the ground level. And so we've built a liftgate in partnership with a company called Anthony Liftgates, who is an expert at building liftgates and a liftgate manufacturer that we really enjoy partnering with. And we've put together our own liftgate, and it operates twice as fast as a standard liftgate, has no hydraulic oil, no failures. Instead of taking 30 person-hours to install, it takes 5 person-hours to install. It weighs less. There are no failure points. There are no hoses that are getting bent all the time. So our customers are really excited about the tech. And the ROI on the system is huge because we move twice as fast as a traditional liftgate. And if you look at the food and beverage industry, the operator is typically spending 1 hour a day just going up and down on the liftgate. So by running twice as fast, we save them half an hour a day, which would allow them to add one extra delivery stop, which is worth between $300 to $1,200 a day. And that multiplies very quickly. And so the increased cost of our new tech is returned within 6 months. So that's an exciting product for us.
I was going to ask about the speed actually, because I was watching a truck lower its back. I guess that's also part of the liftgate technology with an entire load of deliveries for a supermarket. And I could see just how slow it was going. And I wasn't sure whether that was because they didn't want to topple the delivery or whether it was just the nature of the hydraulic system installed in the truck.
It is the nature of hydraulics in general, which is if you want to go fast, you have to add pressure. When you add pressure, you end up wearing everything out much faster. Number one. Number two, at certain levels of pressure, the equipment is actually unsafe to operate without protective equipment because a hydraulic oil leak can actually cut through you if it's running at 6,000 PSI, right? So you just have to be very, very careful. On an electric system, though, pressure is equivalent to voltage. And we're running a 48-volt system. We haven't even gone all the way to 220 or like most electric cars or even electric forklifts are at 400, 600, 800 volts. Oh, wow. So with a fully electric system, you can deliver a lot of energy as long as you're running at a high voltage. And, voltage is not something that bursts. You insulate it well, and then you're good to go.
You remind me back of our discussion about the hydraulic crane, the LEGO crane. And I do remember when I was playing with it, because it was a pump system, I think I remember trying to over pump it and I saw pieces breaking off because it was just not handling it. So yeah, I guess, listeners, if you want to experience it yourself, don't do it with the real thing. Go get yourself a Lego set and you'll start to understand the limitations.
I had the same experience, right? Yeah. I'd over pump it and then the hose would just pop off the part because there was so much pressure pushing the hose out. Yeah. Of course, in hydraulic systems, they clamp the hose down so the hose can't really separate from where it's anchored, but it just means that now the hose is going to burst itself. And there's no way to know when that's going to happen. But with our system, we can tell you when something's going to fail.
Which is also an additional benefit. I mean, you definitely want failure recognition ahead of time. But no, incredible to see all the different applications and also that it's really going in different trajectories as well. And I mean, you came on as CEO in 2024, so it's been a year and 9 months. But I guess, from someone who's also been in a lot of advisory and leadership positions, I mean, what are some reflections that you can offer to anyone, stepping into these kinds of big roles? Were there any initial challenges? Because you did mention they worked on exoskeletons and then they went over to the new technology. What about reflections in terms of how you would go about managing such an innovative company as well?
That's a great question. This is true of RISE, but it's true of every project that I've worked on and every project that I've seen other people work on, where I feel like I could have cut more scope. There's always more scope to be cut. When folks think they have an MVP, you can get people in the room and say, we want to cut scope and focus on that. And you can always find things that you're willing to give up and get things out to market faster. So one of the things I would do differently is cut scope even more aggressively. I mean, the first thing I did when I joined was to kind of do a strategic review, which is where do we want to allocate our resources, right? Just to be very brass tacks about strategies. Where are you putting your resources? What projects do we want to continue? What projects do we want to stop? And as a company, we decided to focus on those projects that were going to get to market in the 6 months to 2 year timeframe. And that's still our focus. And then as part of that focus, we went through and we said, okay, here are the projects we're going to pause. And of the projects we're continuing, here are the areas where we're going to cut scope so we get to market faster. So all of those things went well. I had to fundraise. We basically took our previous round and we opened it to the public so anyone could invest. We had a lot of followers that were excited about RISE in the local area, including people that delivered product to us and so on. So that was the other step I did, which is, okay, how do we raise money and get the company funded? And then the last piece we've been working on is culture, which takes a longer time, which is, what are our norms? Who are we as a company? I define the values very early, but the behavior norms and expectations and so on are kind of the next thing that I'm working on. And I think after this point, it's just going to be about how much gas we can get, because I think we're ready to start scaling soon.
That's incredible. And we'll definitely put a link in the show notes to RISE and all the details as well about the technology in case anyone's interested, and they can definitely check it out and learn a lot more as well. I guess if people have an interesting idea for the technology, can they suggest it to you and approach you?
Yes, they can. Certainly, we're interested in applications, and we're also interested in folks that want to be part of our journey and want to own a piece of the technology. So in either instance, they could fill out a form on our website, riserobotics.com, and express what application that they think we should look at, or if they're interested in being a partner in some way. And if they want to become a part owner in the company, they can go to invest.riserobotics.com and check out the terms there and see if that's of interest to them.
So definitely very different ways to get involved in case you're interested. But Hiten, it's been fascinating going through your journey in robotics and really touching upon the human side, the machine side, and really the whole spectrum of it, which has opened my eyes on, just how broad this field is, but also how we have to rethink how we do things in a world that is trying to electrify as well and to adapt to the future and to be environmentally conscious. And you've definitely demonstrated that with RISE Robotics. So definitely thank you for sharing your journey there.
Thank you, Peter. This is an incredible experience for me. You asked some questions that I was not expecting, and it was delightful to jump into those.
Like I do with every guest, I'd love to ask you a few key questions so that listeners can get to know even more about you. And I suppose the keyword innovation really sits, at the forefront of what you've been doing and really building robots for practical purposes to change people's lives for the better and to also save lives as well in many of the examples that you've mentioned. But in your view, what does the word innovation truly mean, and how has it shaped the way you approach challenges or opportunities in your work?
The easiest way for me to describe how I think about innovation is to contrast it with invention. Invention is something new, building something that hasn't existed before. Innovation is doing something that's perhaps new, usually new, but more importantly, is something that a customer is willing to pay for.
Interesting.
And so RISE has 5 values. Our number 2 value is customer focus. And we get to innovation not just by thinking about the problems we want to solve, but really thinking about the problems that the customers want us to solve. And in a B2B context, actually, it's much easier because we position our products as something that make our customers more money, that save them money, and that reduce their downtime. And so that's where we see our innovation story and how we help our customers.
And it really shows that the idea is worth pursuing because there's really a need and a pain point that you can address.
That's right.
Yeah. But I love the contrast with invention, actually. We haven't had that before when I asked this question. So very nice one to bring that in. Got me thinking as well about, when you think invention, it is really something completely different. Maybe the use is not immediate, but that's where you innovate, I guess. And that's how fitting the word is. Was there a key moment, book, event, or person that completely changed the course of your career or your mindset? We spoke about the Legos, but anything else?
So my time at iRobot was incredible, very, very energizing. There were a lot of people that I ran into that have gone on to do really big things. So Colin Engel certainly was the CEO of iRobot, but he's gone on to start another company. Helen Greiner was the president at the time I joined, and she started a couple of companies after that. Rod Brooks, who was the CTO, started another company. We had a gentleman by the name of Martin Bueller, who became the head of robotics at Johnson & Johnson. One of the folks that I worked with was Vice Admiral Joe Dyer. He was a 4-star admiral, and he was an incredible mentor. There were just an incredible number of leaders at iRobot that have gone on to do really great things. And just being around those people was energizing. It sort of helped me understand that I could do a lot more. And really, I think for anyone that wants to be successful, the best advice I can give them is to surround yourself with other people that you respect, that excite you, that motivate you, and you'll find yourself in the same journey.
Because they open your worldview, they broaden it from, I guess, what you're an expert in to what you didn't think about.
That's right. And also to understand what's possible.
And I guess they can also point out the flaws in your thinking and won't hesitate to as well.
That's right. Yeah, if you can build up a mentoring relationship with folks like that, then you have a lifetime of advice and guidance, which has been very useful to me.
Incredible. So what is your favorite childhood memory other than Lego?
For a short time in my life, we lived in this town called Jamshedpur in India. And Jamshedpur is famous because a lot of Tata manufacturing facilities are around that area. And one of my favorite memories is going for a walk in a nearby park. And there were two things about that park that was interesting. There was a cage of rabbits. I must have been about 6 years old at this time. So there's a cage of rabbits, and they had hay that they could feed on. But if you got them pieces of grass or leaves that were fresh and you put them in through the cage, they would love to come and eat those. So I loved feeding the rabbits grass and leaves and seeing how delighted they were just to get a different kind of food. And that particular park also had eucalyptus trees. And I would love to take the leaves of the eucalyptus trees that were dried and on the ground and crush them and smell the eucalyptus oil. Those were some of my youngest, earliest and favorite memories.
I definitely remember eucalyptus from my time in Australia. Definitely a unique smell and has a calming effect. So I can imagine. And as a child, when you discover a particular smell in a plant, you just have to go and try it. I mean, I remember picking certain flowers because you could taste the nectar from them as well. So yeah, lots of these curiosities. But that's interesting.
I have something funny to add there. The rabbits did not like to eat eucalyptus leaves.
Oh, no?
Well,
I suppose
they're not edible.
You had to test it, right?
That's right. It's like, this smells really good to me. Do you want to eat it?
It's like, no, I'd rather smell it. No, but it's lovely. And so what was one of the most challenging situations that you've ever faced in your career to date, and how did you overcome it?
I'd say one of the most challenging career situations for me was when iRobot decided to pause the launch of the robot lawnmower. I had spent 5 years on that project. And during some of that time, I was also running the mechanical engineering, industrial design, and test department. And so I really wanted to take that product to market. And so I had told my wife that for 2 days a week, Tuesdays and Thursdays, I'd work as long as it took to get all the work done. And I'd find myself coming home at 1 or 2 a.m., just getting things done and then finding a way to get back to work at 8. And my wife was very supportive through the whole journey because this was something I really, really wanted to get to market, something that I could call my own. And when COVID hit and the company decided that they had to pause every expansion project, 2/3 of my team got let go. And that was very difficult because I'd worked with these people for 5 years. I'd led them through the journey, and I felt like I'd let them down, because if I had found a way to even shave 6 months off the schedule, we would have launched 6 months previously and the project wouldn't have got canceled because we would be in the middle of it. And it turned out that in the middle of COVID, people started to get more involved in their homes. So Roombas at the second half of 2020, Roombas started flying off the shelves because people were working from home. We had established a new normal and everybody wanted to clean their homes and they wanted better maintained yards because they didn't want the landscapers coming in making noise while they were working from home.
Yeah.
So if we had launched 6 months previously, that whole team would have stayed together and we would have had an incredibly successful product because it just would have been flying off the shelf. And so the pressure of time weighs on me, which is we got to find ways to do things faster. And one of the easiest ways to do that is to cut scope. And even in that project, I look back and say, I could have defined an even tighter MVP and we could have launched. So it's one of my biggest challenges and also regrets.
I mean, it's something that could not have been predicted, looking back at it. But at the same time, I guess it taught you a very important lesson about, cutting scope or, simplifying things as a result. But no, thanks for sharing that. And I don't lead a team yet, but I can imagine the amount of pressure that gets put onto you once you hire your first person and then managing a small team itself, feeling responsible for all of them. And then something like this happens. So how do you then, other than the learnings, how do you then deal with the initial shock of when that happens and when the actual event hit?
So what I decided to do then is that energy had to go somewhere. And so I decided that I was going to try to find a way to hire back all of those people. And maybe I couldn't hire them back at iRobot, but I could hire them back in some other organization. And so I asked iRobot permission to spin out that product line as its own company. And they, at that time, gave me permission to go seek venture funding to see if I could start a company that would take this to market. So I went through the whole process, and ultimately, by the time I had the funding lined up, iRobot's business had recovered, and they were thinking about restarting the lawnmower project again. And so the timing didn't work out, and also they had started hiring back some of the people that they had let go. So the key to my motivation was also getting addressed, and companies had started to hire again. And so I just, at that point, was ready to let go of that event that happened and kind of move on to the next thing. But for, I'd say, 3 months, I was entirely focused on finding a way to keep that product alive, find the external funding needed to keep it going, and find a way to basically bring the band back together. But sometimes, you can't do it. Things change, circumstances change. The team started to find work, and there wasn't enough critical mass left to actually build a company out of, and the funding came in too late.
Yeah. But in a way, it sounds like certain parts of it did turn around in the end for the better. And in a way, a big learning experience. But finding a way to turn that adversity into something that's greater and to, sorry, I'm lost for words here because it is an incredible story. And it is, I also feel if that ever happened to me, I would have that same drive to try and get the people back that, you build a relationship with for such a long time, working on something that is very close to your hearts and that you're incredibly excited about. So, yeah.
That's right. The work that I had to do to try and hire all those people back was completely new from what I had been doing previously. So I had to start knocking on VC doors. I had to start getting warm introductions. I had to reach out to my network. It was a very different thing than leading teams of product development experts. It was essentially entrepreneurship. And that passion to try and get the team back together ultimately is what led me to where I am today, where I've had the opportunity to be CEO or president now of 3 companies. And it all started with me saying, I'm going to find a way to raise money to hire these people back. Although I was not successful in that whole journey gave me experience and understanding of what investors were looking for and how a business should be structured and what kind of returns they were looking for and how much money could I feasibly raise and how to talk to them about TAM and how to talk to them about the team, how to talk to them about traction. All of those learnings ultimately ended up landing me my next gig, which was as head of product and strategy for a company called Mobot. And then eventually I became their CEO, which then took me to Electric Sheep. And It was a transformative experience. It's amazing what you can do when you're really tested. And I was really tested at that time.
And it's an incredible story of vulnerability. So thanks for sharing it.
This is a wonderful question. Thank you for asking.
And so you've given some wonderful advice already to young professionals, seek out mentors, seek out people that can open your worldview. Any other advice you can offer to young professionals starting out, perhaps young mechatronic engineers interested in robotics?
Well, I would say that for everyone, they should get some amount of experience and then they should try and start a company of their own. As long as they feel like they've got the resilience muscle, which is the most important thing when you start a company. You're going to have so many failures and so many challenges thrown your way. The one thing you need to learn is how to get back up and keep going. And if you do that, if you take enough at-bats, if you swing the ball enough, you'll hit a home run, as they call it in the United States, or a sixer, as they call it in cricket. But you've got to be able to get up and try and try and try.
Yeah, resilience, I guess. It's a tough skill to learn, but if you have it, you can do incredible things. Great advice. And so, Hiten, as we near the end of this episode, the final question, the existential question that my guests always, I guess, they find it very challenging, but at the end appreciate it as well, which is, what would you most like to be remembered for?
Improving the lives of people. So, one of the things that really two things that really excite me about RISE Robotics is that energy efficiency is the key to making an impact on global warming. If we can just run everything 3 times as efficiently, we'll clean up the environment, we'll emit less greenhouse gases, and we'll address the problem of global warming. So I'm excited about that. But then the additional speed of the things that we build, the equipment that our actuators go into is really the backbone of the economy. And any efficiencies that we create ultimately translate into a reduction in the cost of goods and have an effect of making things more affordable for everybody. So RISE allows me to pursue that particular passion. And when we're successful, I hope to be remembered that I made the lives of other people better.
Fascinating and incredible. So where can people find you if they want to get in touch?
Well, you can certainly find me at riserobotics.com. And there's a form there that you can fill out. You can also reach out to me on LinkedIn, and we can start up a conversation there.
Definitely. And we'll put that as well as notes to many things we've discussed today in the show notes so that listeners can delve into the world of robotics or, look at some Lego sets that inspired us as well to go into, or at least to have an interest in robotics. Hiten, it's been a pleasure having you on the show. It's been fascinating learning and going deeper on this field, which, if things had turned out a different way, I probably would have gone down this road as well. But yeah, either way, thank you for sharing your story and your journey. And like I do with every guest, I always give my guests the final words. So take it away.
Peter, this was an incredible experience. Thank you. It's one of the best podcasts I've done. The questions you asked are so deep and require insight and thought and really helped me open up in a way that I haven't in a long, long time. So thank you for helping me reminisce about my past and connect that to my present. Really appreciate you.
Thank you so much. And that wraps up our fascinating, nostalgic and eye-opening episode with Hiten Sonpal. For more information on the latest in household robots, the LEGO catalog from the early 90s, or tips on leadership, product to market and scope cutting, check out the show notes for more information over at tgcpodcast.show. And as always, thank you listeners for tuning into this episode and for your feedback and support. If you are enjoying this show, I would be incredibly grateful if you could share this podcast with your family, friends, colleagues, and even fellow geeks. Follow this podcast on Spotify, Apple Music, and other podcast channels to stay up to date with the latest releases, or be part of the conversation on Instagram at tgcpodcast_official or our LinkedIn group. If you're curious about me or my work in general, you can also check out my website or social media. Head to petermbach.com, my YouTube channel Peter Marcus Bach, that's Marcus with a C, or Instagram at petermbach87. Give me some feedback or suggest a future guest so that I can keep improving this show. The podcast's intro and outro song is called Starsky by Alex Kieran. Stay tuned for our next episode and next guest to hear how they are tackling the grand challenges.